A Coast Guard cutter detects an unidentified ship at a distance of 20 kilometers in the direction of 15 degrees east of north. The ship is traveling at 26 kilometers per hour on a course of 40 degrees east of north. The Coast Guard wishes to send a speedboat to intercept the vessel and investigate. If the speedboat travels at 50 kilometers per hour, in what direction should it head? Express the direction of compass bearings with respect to due north. Anyways, folks, so both of these ships are traveling east of north. I encourage you guys to pause this video and to give this problem a shot, presuming you pause this video. So this is going to be the x-axis, and this is going to be the y-axis. And a Coast Guard detects an unidentified ship at a distance of 20 kilometers in the direction of 15 degrees east of north. So this is going to be 15 degrees from here, I think. I'm not 100% sure. And that's going to be east of north. And it detects a ship that's like, I don't know, 26 kilometers per hour. Wait, what? 20 kilometers in the direction of east and north. All right. So this detects a ship at 20 kilometers at that angle. 15 degrees east to north. The ship is traveling at 26 kilometers, a course of 40 degrees east of north. So now you're going to have a ship that's going to angle a little further down, I guess. I know I didn't do it that well, but that's okay. And that's going to be 40 degrees, and it's going to have some component and it's traveling at 26 kilometers per hour. Okay, so before we do this, let me draw the vector of the Coast Guard ship as a function of time. So I'm going to call that R. So R of the Coast Guard, of the ship, I'm going to define this as the initial position, which is going to be is 20 kilometers, sine of 15 degrees in the I hat direction, added to 20 kilometers, cosine of 15 degrees in the j hat direction. Now this is just where it initially starts. Now it's going to travel at an extra distance of 26 kilometers per hour times. So this is going to be the initial position. So this is going to be traveling at 26 kilometers per hour times the time, sine of 40 degrees in the I hat direction, added to 26 kilometers, cosine of 40 degrees per hour times the time in the j hat direction. So notice, folks, that this is going to be the setup for the RS. Now what's going to happen is a Coast Guard is going to send a speedboat to intercept the vessel to investigate. So it's going to want to travel from this point to that point. So it's going to want to maybe, so it's going to want to catch up at that exact same position. So in order to do that, this is where it starts when t equals 0. It starts at this point. This vector is going to increase. Notice that the reasons why I don't use I hats and j hats, but that's all right. But think of these as points. You start at some initial point and you're traveling at some direction, which is 26 kilometers per hour. So, and they send a boat that's going to intercept the vessel. If the speedboat travels at 50 kilometers per hour, at what direction should it head? So, if this thing travels at 50 kilometers per hour, what direction would it send? Notice that this direction, this angle is going to vary, because if this is going to go more in that direction, it's going to get further. In fact, come to think of it, would there be a limit? What would be the limit if it's going all the way here? I guess this angle would be relatively fixed, but whatever. I think regardless, folks, I'm going to set up the other equation. So the R of the boat is going to be some angle, which what's the speed of that boat? 50 kilometers per hour times the time at some angle, which is cosine of theta. I'm going to define theta to be here in the I hat direction, plus 50 kilometers per hour times the time at sine of some angle in the j hat direction. So what we're going to be doing next is we're going to be letting the r of the speedboat be the vector r of the boat. So we're going to let this component equal to this component. So you're going to have two equations, two unknowns, and once you solve for theta, theta is going to be 26, well, I kind of looked it up, 62.3 degrees. All right, we're done.